Powder is a facility that provides programmable network hardware and software deployed in a real living laboratory environment. In this video, we'll be talking about the base stations that Powder is deployed, what's in them, what you can do with them, and where they are. In Powder, a base station is composed out of several radios connected to front ends and antennas. Powder base stations are on building rooftops to get good coverage of the surrounding areas. In many cases, they're in the same locations as commercial LTE and 5G base stations. They're connected via dedicated fiber back to our data centers and are capable of transmitting at fairly high power levels. It's important to note, though, that what the equipment actually does in any given experiment is defined by software. So, while the main use case for these locations is as traditional base stations, they can be configured to act as end stations, mesh networks, or anything else. Let's start with a look at the antennas on a typical base station. Each base station has a few antennas on it because different antennas provide different functionality. One antenna from CommScope provides a number of ports for the 1.7 to 2.7 GHz, 3.4 to 3.8 GHz, and 5.15 to 5.9 GHz bands with moderate gain. The other from Keysight provides broadband access from 20 MHz up to 6 GHz with low gain. Each antenna port is only used by one experiment at a time. The antenna is connected to an RF front end that provides duplexing, filtering, power, and low noise amplification. Our base stations currently have front ends with power amplifiers that provide 4-watt peak power, low noise amplifiers with less than 2 decibels of noise figure, and duplexing and filters for band 7. These are connected to the CommScope antenna. Like antennas, front ends are not shared between experiments. There's currently a 1-to-1 mapping between radio ports, front ends, and antenna ports. When deciding which base station to use, and specifically which device to use in that base station, it's important to make sure that the device is configured with a front-end antenna that will work with the spectrum that you're using. Now we get to the part where you can really do some programming, the SDR itself. The SDRs in most of our base stations, all those except for the massive MIMO, are USRP devices from NI. Specifically, they are N310s and X310s with UBX 160 daughter cards. They both have the ability to run at frequencies from 10 MHz to 6 GHz. The N310s support a bandwidth of 100 MHz, have Zynq 7100 FPGAs on them, and 4 channels. The X310s support a bandwidth of 160 MHz, have Kinetic 7 410T FPGAs, and 2 channels. One of the key features of Powder is that users have direct, exclusive access to these devices, including the ability to program the FPGA. The SDRs that we use in our base stations use 10 gigabit Ethernet to talk to their hosts. Each radio uses a different wavelength transceiver and is fed through a CWDM multiplexer on the rooftop, a fiber pair back to our Fort data center, into a demultiplexer there, and finally to a Dell switch. These switches are fully provisioned to provide full bandwidth to the SDR and introduce very little latency. Using Ethernet for SDR to host communication provides us with the highest bandwidth available in the USRP line, and it enables any SDR in the base station to be paired with any of the servers in the data center, which we will talk about next. To handle signal processing, we have Dell R740 servers in the Fort and MEB data centers. Each one has 196 gigabytes of RAM and 24 physical cores. The most common usage pattern is that each gets paired up with a software-defined radio. You select which SDR you want, we select a server for you, and then we wire them together through the Ethernet fabric. Like other resources in Powder, you get exclusive access to these devices so that you can do real-time processing. To wrap up the equipment that's in the base station, each base station also contains support hardware that is part of our infrastructure. These include power controllers so that we can remotely reboot everything if necessary, and serial consoles for out-of-band communication in case there are any network or firmware problems that need to be addressed. We have environmental monitoring that can shut things down if the temperature gets too high or too low. Powder has a bring-your-own-device program where we will install some kinds of experimental hardware in our base stations and other locations, and this support infrastructure is available to control and monitor those devices as well. The base stations that we have right now are deployed on building rooftops around the University of Utah campus. Our goal in placing them is to be able to cover most of our campus so that we can place fixed endpoints anywhere in this area. Our locations are also intended to cover most of the bus routes on our campus so that we can deploy mobile nodes on the buses and have them hand off from base station to base station as they drive around the campus. You can find more information about Powder on our website at powderwireless.net, including more detailed maps, hardware specifications, and more. Thanks.